we're on Chapter 3, Lesson 4. Please turn to page 201, multiplying decimals by decimals. So again, in this case, since we have decimals by decimals, you're going to have to count both sets of place values to the right of the decimal, and then you're going to have to add them. Before hopping to the left. Okay. All right, let's look at the real world problem. All righty. The table shows the weight of a 1 pound object on each planet. Wow, this is interesting. So we know that on Earth it's 1 for 1, and then on the other ones, ooh, Jupiter, boy, we would be really heavy weighted on Jupiter. And then everywhere else we'd be about the same or less. So a 5 pound object weighs a half pound as much as a 1 pound object. If a cheeseburger weighs a half pound on Earth, what will it weigh on Jupiter? Okay, so we know the multiplier in this case is 2.3. So we've got half of 2.3. I'm going to do this in terms of money just to see if you could do this. I'm going to cut $2.30 in half. That would be $1.15. Did you guys follow? I know you do money really well. If I did the actual math of the problem, I would have set up 2.3 times 0.5. That's a 5, that's a 1, that's a 1, 1. 1 here for a total of 2, and I got the same answer. So again, I'm always going to try to think about things in terms of money. So a 5 pound object on Earth, what would it weigh on Jupiter? So again, we're multiplying by 2.3. Well, we know that 5 times 2 is 10, so that's the first part of it. And then 5 times 0.3 is 1.5 for a total of 11.5. And again, I'm trying to have you look at math a little bit differently. Turn the page. Let's start the work. All right, when multiplying, we're going to multiply and then move the decimal. But before we do that, we always have to again think about estimating. Can we estimate before we do the problem? In this case, we have approximately 4 times 0. Yeah, that doesn't get us anything. So our estimate again is 0. So that's not going to help us. So we have to be very careful with our decimal placement. In this case, we have 1 decimal place here, 2 here, for a total of 3 bunny hops. 1, 2, 3. So our answer is 0.18, which again is closer estimate of 0. Decimal placement is crucial. Bunny hop counting is crucial. Put it in a box, you won't forget it. Let's look at number 2. In problem number 2, let's wait for the bell. In problem number 2, we have 0.112 times 7.2. So we've got a hair under. I'm going to go ahead and say that our estimate really is going to be about 1. So it's going to be somewhere between 0 and 1. So let's go ahead and do the math of this. We have 2 times 2 is 4, 2 times 1 is 2, and a 2. I always put my x as my place value. That's a 14, that's a 1, that's an 8, that's a 7, that's a 4, that's a 6, that's a 0, that's a 1, that's an 8. We have 1, 2, 3. We have 3 bunny hops here. We have 1 bunny hop here for a total of 4. 1, 2, 3, 4. So we have 0.8064, which is approximately 1 if we were to round up. And again, if you had said 0, 0 and 1 are the same, it looks good as an estimate. What you know is that your answer is very, very small, and counting the bunny hops is very, very important. Okay, get it, gotta go. See you soon. Pause the video. Okay, A, I got 15.96. My estimate was 18. 18 looks really good with my estimate. I believe that. The next one I got 0 for my estimate, which meant I had to be really careful. So when I did it, I had 4 bunny hops. Notice that the last 0 on the end disappears because it's not necessary. You need it for bunny hops, and then you can get rid of it when you write your answer. And the last one, number C, when we did it, I have it again an estimate of 0. But in this case, I had to annex or place a 0 because I had 4 bunny hops and only 3 digits. So I needed to bring another 0 in for my answer. Okay, turn the page. So again, here we have that word annex again, which means equalize or put a 0 in. If you do not have enough decimal places in the product, you need to annex zeros to the left. So again, when we look at this, our estimate is 0, so we have to be really careful. We have 3 here, 1 here, for a total of 4 bunny hops here. 1, 2, 3, 4. We had to annex or place a 0 so that we had 4 decimal places. All right, let's look at number 4. All right, number 4, we have 0.45 times 0.053. So again, we have 0 as our little estimate. And we know 1, 2, 3, 4, 5. We're going to have 5 bunny hops. So we're going to have 2 bunny hops here, 3 bunny hops here, for a total of 5 bunny hops here. That's a 15, carry a 1, that's a 13, that's an X. That's a 25, 2, that's a 22, that's a 5. That's an 8, that's a 3, that's a 2. We've got 1, 2, 3, 4. We need 1 more. And there you go. So in this case, it's 0.02385. Multiply related whole numbers. We're not going to do that because, again, we're going to be very careful by placing our decimal places in a box and bunny hopping. So we're moving our decimals 5 places. Go ahead and get it done. See you soon. Pause the video. Did you get the same things I got? 0.0128, 0.0533, and 0.0798. In number E, I took off the last 0 because it didn't have any value to my number, but it was necessary when I was counting my bunny hops, which were 5. So again, notice that the estimates for all 3 of these are 0, so making sure that you place the decimal in the right place is crucial. Putting your numbers in a box, counting over, doing it with a visual check instead of in your head will always save you. Turn the page. In our last problem, we have a word problem. A certain car can travel 28.45 miles with 1 gallon of gas. The gas tank holds 11.5 gallons. How many miles can this car travel on a full tank of gas? So then that's 30 times 11, approximately, which is 330. So I'm going to go ahead and put my guess in a cloud. Now, notice in this case we have a line equal line, and we have miles and we have gas. So we know we can go 28.45 on 1 gallon, and it holds 11.5 gallons. So we're looking for how many miles in 11.5. So when we do the math, again we have 2, we have 1, for a total of 3. 1, 2, 3, and we get 327.175 miles. And again, we estimated 330. Our check is good. Go ahead and do the guided practice. See you soon. Pause the video. Did you get what I got? 1 is 0.3 or 30. I don't need that 0 at the end. Number 2 is 29.87127. Notice my estimate was 27. Pretty good guess. And then the next one, my guess is 7, and it's 7.154, which was very close. My next one, my guess was 2. Could have been 3. I can see how they got 3. But again, I knew it was 1 digit for the whole component, 3.645. The next one, decimal placement is hugely important because I know that the answer is way in the weeds of 0. So again, I have to make sure that I do the right bunny counts. 2 on the first one, 2 on the second, for a total of 4 bunny hops, meant that I had to annex 2 zeros, or put 2 zeros before the decimal. And then the last one on these kind of computations was 0.0848, and again, my estimate was 0. Had to be very careful when I counted it. 1 mile is equal to 1.609 kilometers. How many in 2.5 miles? So I have an estimate of 4 because I have 2 times 2, which is 4, is how I estimated it. And you get 4.0225 kilometers. Pretty good guess. So again, 8. Why is estimating not helpful when you have very small numbers? Because your estimate is 0, therefore your bunny hops or bunnies in a box becomes very crucial. Be very careful. Good luck. See you soon.